Welcome to Part 2 for Section 1.1. We're going to talk about what a distribution is and the distribution of a variable. One way to examine a single variable is to graphically display its distribution. The distribution of a variable tells what values a variable takes on and how often it takes on these values. Distributions can be displayed using a table, a graph, or a function. If displaying using a graph, the proper choice of a graph depends on the nature of the variable. For example, if we have categorical variables, in other words whose values categorize, we would use pie charts or bar graphs. If we have a quantitative variable, we would use, for example, a histogram or a stem plot. We're looking at a frequency table and a relative frequency table. And we're going to look at this. It's the class makeup for the first day of class. And we have freshmen, sophomores, juniors, and seniors in that class. And we count the students. We literally count for a total of 43 students in that class. And we can find the percentage. So we'd say 18 divided by 43. That gives you the 41.9%. Now, of course, we're rounding off to get these percentages. And when you round off like that, you're going to have a little bit of trouble because when you add the percents, it should always be 100%. Since we have a little bit of rounding error, we're going to in this case go a little over 100%, and that was just due to rounding error. If we rounded and went a few more decimal places out, we'd have a more accurate answer. Now this is a graphical display of that same data. So graphical displays are a wonderful way to show our data. It gives a good picture. This is a bar graph of the same data. And again, you can see the highest bar goes to freshman, and the next to sophomore, and so forth. So you can see the data with a bar graph too, very nicely. Now we're going to look at U.S. solid waste in the year 2000. And we have the different types of waste, their weight in millions of tons, and then their percent of total. So we can look at the waste, the U.S. solid waste. So let's look at the first graphical display of that. So here we have a pie chart of that same data. So as we can see by this pie chart, paper is clearly the largest category for U.S. solid waste. Or a great picture of what's going on with the solid waste. And here's a bar graph. But whoa, wait a minute. I thought they said paper was the most. What's going on here? What do you suppose is wrong? Well, this is not the same graph. This is not the same problem. We're now looking at percent recycled, not just percent waste. Now, why do we do this? Why do we show you this? First of all, you want to make sure you have good titles. So this talks about U.S. solid waste, but it wasn't a good title. It should be U.S. recycled solid waste. You could confuse yourself. You could confuse whoever you are giving a presentation to if you don't make very good titles and try to make sure that the titles are very easily seen. So that little percent recycled, not good. And if you were given a presentation, you could actually confuse yourself. What you want to do is whenever you do a PowerPoint presentation is you always want people to be able to look at your graphs and your presentation and have very little questions about what's on that graph. So now we're going to look at how to do our own graphs, and I'm going to pull up Minitab and we're going to work through this. So we're going to organize our qualitative data. We're going to do bar graphs and pie charts. Now how can we do this? Well, we saw a couple. We can make a relative frequency distribution. It's just that table where you see the categories and the values, or the relative frequency distribution where you see the categories and the percent that each of the values has. So here we have an example. This is our raw data, these different colors, blue, blue, green, red, red, blue, red, blue. And we're going to make a frequency distribution for this qualitative data. So we're just going to put in, so we count how many blue and we put that number in. So there were 4 blue, 1 green, and 3 red. So we can now look at that frequency distribution and say, hey, there are, which color it most commonly occurs? Blue. So we can answer these questions. So we see that we have 8. Remember, there were 4 out of the 8 that were blue, 1 out of the 8 that were green, and 3 out of 8 that were red. And in statistics, we can leave it unsimplified, or we can go down and simplify the fraction, or even do the percents and decimals. So we could add those in, so we could represent the relative frequency in any one of those ways. So let's say that we wanted proportions. That means just fractions. We could put that in and do a relative frequency table with proportions. And I'm going to leave them unsimplified, because it's nice when you do that if you add those fractions that better equal 1. And so we could put in the percents just like that. And this is what the bar graphs would look like of the same data, a picture of that data. Now when we look at this, one is a frequency bar graph, one is a relative frequency bar graph. The bars relative to one another look exactly the same. It is the scaling on the left side that is different. So one is counts and one is percents. And what we're going to learn is how to make very good titles and for these graphs and labels for these graphs. So these are not the best titles and labels per se. And here's the best practices for making good bar graphs. First of all, your horizontal scale, the categories should be equally spaced. The rectangle should have the same widths and have some space between them. The qualitative variable associated with the category should be identified via a meaningful label. Now the vertical scale should always begin with 0, and the increments should be reasonable. Go somewhat but not significantly beyond the largest frequency or relative frequency. And it should be labeled in such a way that it's clear whether it's a frequency bar graph or a relative frequency bar graph. And the overall graph should have a very meaningful title identifying qualitative variables whose description is being graphed. So here we have our phlebotomist example. A phlebotomist draws the blood of a random sample of 50 patients and determines their blood types. We will use Minitab to create some graphs, and this data is found in that file that says Minitab examples. So we go onto Blackboard and we'll get the data. So we go into our course content, go into our Minitab examples, and there you see Minitab commands for bar and pie charts. Our blood type example. This is if you want to use commands and to find out what exactly the problem is. The file below it is the data that we're going to use. So we open up Minitab. As you can see, Minitab has what's called a worksheet area. If I click in here, anywhere in here, this turns darker color, so I know that I'm working within here, and all these tabs would then be working inside here. So editor, this would be editing the, the worksheet. If I click up in the sections window, this became darker, and all the commands will be for my section window. So if I go into editor, I have a whole bunch of different commands. So the first thing you do when you enter Minitab is go into the sessions window and enable the commands, meaning we get our Minitab prompt, the MTB prompt, that prompt right there. That would allow us to be able to do commands. So we're going to go on and we want to do a relative frequency and frequency tally, or frequency chart. So that's the first thing that we're going to learn how to do. I'm going to teach you using drop downs. The commands are in those files. And we're going to stop here. And in the next installment, in part 3, we're going to be working in Minitab.